Welcome to the shop. Well, the machining work is finished, and now it's time to get going on the electrical work. There's a whole lot of electric work, wiring and surface mount soldering, and a lot of other stuff that needs to be done. The NQALHA, of course, is an electromechanical device with a lot of electric. So what I'm going to be making here is the cable harness, the main cable harness. And I'm using a board with some springs on it and a list of the wire colors that go to the various locations. This is a kind of a crude approximation of a technique that is commonly used in the aerospace industry when building the wiring harness for an aircraft or a spacecraft. Obviously they use nicer fixtures, but this thing, crude and ugly as it is completely effective and does a fine job and allows me to fairly quickly and easily get all the wire lengths right without having to struggle with curled up wire coming off a spool and trying to get it with a tape measure. I just put it in, stick it in the springs, and you'll see when I get going here. So time to make cable harnesses. I use a technique on the NQALHA called home run wiring, and that is that when I have something that's very common, like the 12-volt power, instead of running one thick wire and then doing things like having inline splices or Y connections, I run a lot of smaller wires. So all of the purple wires that I'm running now are all the same thing. They're all 12 volts DC, but they go from a different point to a different point. And to simplify things, when I have higher current requirements than the wire can handle, these wires are rated for about 2 amps apiece, and the total NQALHA is about 5 amps. I just use multiple wires instead of using a combination of thick and thin wires. And as you can see, this goes pretty quick. And then, of course, while I was talking, I made a mistake, so this one actually needs to go here. Talking and working at the same time. So the purple wires are the 12 volt. White is the vertical magnet. Gray is the horizontal magnets, and there are 2 of them. Of course, when cutting wire to length like this, always a good idea to waste a little, cut it a little bit long. So the fixture is designed to be a little longer than it needs to be, and I cut the wires a little longer than the fixture so that by the time everything is assembled, I'm pretty much guaranteed that I won't run into problems. So the black wire is ground, and the last little wire is yellow, which is the foot pedal. And you can see how easily the wires just stick into the space in between the spring coils. One more gray to go. Of course, having the colors printed on a piece of paper makes it easy to double check and cross check. So I got purple and gray, purple, purple, white, gray, purple, purple, gray, yellow, black, black, and all is well. So I'm going to take a little bit of electrical tape and temporarily put a piece of tape on just to kind of keep them together. That this piece of tape will be removed after the harness is assembled, and of course the harness goes inside a piece of flex conduit, which you'll see in the next segment. The total assembly here is designed to be field replaceable, so the ends are all connectorized. If somebody ends up with a problem and breaks their cable harness, it can be replaced using just a screwdriver and plugging and unplugging connectors. So since this is the end that I poke through the conduit, I want to make sure that there's nothing bent over on the end and that it has a nice little piece of tape somewhat carefully applied to make a nice uniform little sliding surface. So there we have the preliminary cable harness assembly, and I'm going to go ahead and make a bunch of them and then turn the camera back on and poke them into the conduits. So see you later. Now I'm going to be putting the pre-made, pre-cut cables into the metallic conduit. These are the little aluminum parts that I made in previous videos. The flex conduit was cut to length off camera and then epoxied into place. And I didn't show that either. But what is important here, let me get my safety glasses. Steel flex conduit can have kind of sharp edges when it's cut, and sharp edges in wire don't get along real well. So I'm going to use a Dremel with a little grinding wheel to clean up the inside and make it smooth so it doesn't scar the wire. The wire is special high temperature wire. It's Teflon insulated, rated to 200 degrees C, and it's pretty slick and pretty durable, so I don't have to worry a lot about the sharp edges scraping the wiring, but I still try to make them as smooth as I reasonably can. Okay, so the ends of the conduit have been ground reasonably smooth, and now I'm going to poke in the pre-cut cable harness, and starting from the end at the connector where the power and foot pedal end up getting plugged, just going to poke it through straight, and there it goes. Unfortunately, wire does come coiled on a spool, and it just likes to stay coiled. So, need to get those two guys to stick out. Here's where the horizontal little magnet in the head goes. Then reverse direction, poke it back through, and then here's where the rest of it goes. So you successfully poked. Now, before I put a connector on this thing, here's another important part that I really hate to forget this. Got to put this little guy on before crimping the connector. You can imagine how annoying it is to have one of these finished and then realize, oh no. So that is the preparation of the conduit. Next step will be connector crimping. I'm not sure, connectors are small and the microscope camera doesn't work very well. I'm not sure how, if and how I'm going to get a video of that, but of all of the operations involved in making an NQALHA, crimping the connectors is the worst. So I'm at the electronic bench now, going to be crimping the connectors. This is the first little connector that I'm going to be using. These are called JST XH connectors, and they're tiny. They're not the tiniest ones. The connectors for the stepper motors are just insanely tiny. So these connectors are made on a strip. And if you have the super duper automated machine, which costs thousands of dollars, the connectors are fed automatically from the strip into the crimping head, and you just stick in a wire and push the button and it crimps. Well, that's fine if you're a serious electronic factory, but for me, I can't afford that machine, so I do it manually. And boy, is it ever annoying. Did I mention this is my least favorite part of building NQALHAs? I think that if the sales pick up to the point where it's justified to do this, I believe there are assembly factories that do this using either cheap labor or the proper tools, and I could probably outsource this work, but at my present levels of production, I just do it by hand. So, using my more powerful, my 3x reading glasses, plus 3 diopter, because this is close-up work. So, you got to strip exactly the right amount of insulation off the wire. The little connector, let me get a long nose plier here. The little connector has 2 crimping points. The back crimping point clamps the insulation, and the front crimping point crimps the wire. And this means you have to be accurate. You have to stick the stripped wire in exactly the right amount so that the wire is crimped in the stripped wire is crimped in the front part, and the insulation is crimped in the back part. If you get this wrong and push it in too far, then the insulation gets crimped in the area that's supposed to be getting the wire, and you don't have any connection. If you use the wrong crimping die and squeeze too hard, you can destroy the connector and break the wire. So it's just a very careful, meticulous process of carefully putting the contact into the crimper, then sticking the wire in just the right amount, and this requires good lighting, magnifying glasses, and a steady hand. Did I mention that this is the least enjoyable part of building the NQALHA? So there are six happy little wires. Then the next step, I go over to the connector bag and get a connector body, and then go over to my set of papers and look at the connector. Remember where pin 1 is. These guys are marked with a little pin 1 mark. And so, gonna be purple, purple. Gray, yellow. Oh, didn't crimp the yellow. The annoying thing is that these wires, they just want to, having once been coiled up, they just want to continue to coil, and it just, another annoyance in an already annoying situation. Did I mention this is my least favorite part of making an NQALHA? Fortunately, I almost never make wiring errors, and these things, even after all the complaining I do, they almost always turn out right. So, next step is going to be to take a tiny little screwdriver and just poke them home. They have each little connector has a little hook on it, and the little hook goes into the little slot here, so they're nicely retained in place. And I have hundreds of these to do, and I'm not going to show them all, so that's it for connector crimping. I'm in the electronic lab now, and I'm going to be wiring up the optical encoder. Now, this little guy, it's a great encoder. It's a high-quality encoder that works really, really well, but it has really, really tiny little pins. And so in order to connect wires to it, there's no way that I could solder wires to those tiny little pins. In order to connect wires to it, I made this little circuit board that has a bunch of holes around the outside that will be filled with solder. And then the tiny, tiny little pins will be soldered to the board. And I put a little 0.1 microfarad capacitor on the board because this thing has active electronics in it, and active electronics likes to be decoupled with a 0.1 microfarad capacitor. Now, a very strange thing about this part, this is a very high quality part, works exceptionally well, but it has a built-in gotcha that was not immediately apparent when I first looked at it. This label that's on the part, you would think that it would be made of plastic. Well, it's plastic, but it's aluminized plastic, so it has actually a conductive layer under the plastic, which means that if you put the little circuit board on there and then put solder in the holes, it can melt through the plastic and short out the encoder. I have no idea why they would do such a thing, but I do have a solution. I'm using Kapton tape. This is a high temperature adhesive tape, and just gonna put, well, it's easier to do it not on the microscope. Gonna put some Kapton tape on this guy. I just can't imagine why they would put a conductive label on the bottom of the part. Seems to make no sense to me at all. So, the part is now protected, and I'm going to go ahead and use my soldering iron here. Yeah, I'm finding one difficulty right away here, that the microscope camera This is normally a stereo microscope, and so I actually have some depth of field when I'm working. Binocular kind of action. But the microscope camera kind of takes one of the eyepieces away, so I'm not sure I'm going to be able to use it. Anyway, there is an encoder prepared for the next operation, and I'm not sure I'm going to continue with this. Wiring is not quite complete, but I did a whole bunch of it. So now I'm getting ready to hand fit the little levers, and probably not going to show up really well on the camera. A lot of the stuff that I do at the electronic bench just isn't going to work really well in video. I don't have a camera operator to get the perfect shot while I'm working. The best I can do is just to kind of hook it up and hope for the best. So the little pieces of rubber that were glued to the levers were cut on the Bridgeport, and they're pretty accurate, but the little switch only has, its full range of motion is only 10,000ths of an inch. And so this surface, the little surface there where, I don't know if a camera will focus on this, but that little end there has to be really within thousandths to feel good. And so I'm hand fitting. I'm not going to be able to show the surface mount assembly with the microscope. I rely on the stereo microscope for depth perception, and the microscope camera takes one of the eyeballs away. So I only get a single eyeball when using the camera, and that means that I can't see where my soldering tip is and really can't work. So there are videos on the YouTube of people doing micro soldering under the microscope. I recommend Louis Rossmann. He repairs Apple products. But my microscope and my microscope camera are just not going to work for the videos of assembly. This is a tedious process, but I want these to feel really, really good. I don't want them to just work. I want them to feel really, really good with just the perfect amount of travel and the perfect little springy feel. And so it usually takes me a number of cycles of putting the board in place. Anyway, I'm not going to show the entire fitting process. You kind of get the idea. Carefully sand on the sandpaper, put it in, see if it works, sand a little more, hope you don't sand too much. And that's about all of the electronic assembly that I'm going to show. Next video will be final assembly of a finished NQALHA, and it will be the last of this series. So thanks for watching. It's been fun.